Okay, this is question 5 of the photoelectric effect questions. So let's jump in. The diagram shows a metal plate, there's an A there that you can take out, that emits electrons when a certain frequency of electromagnetic radiation is incident on it. The plate is connected to a source of potential difference and an ammeter as shown. So really what we're concerned with is the current. We're going to be concerned with the current. First of all, they want the name of the phenomenon. Well, this is the photoelectric effect. We've done that lots. Okay. Then they say radiation of wavelength 555 nanometers. So I know I'm going to have to take this and times 10 to the minus 9 is incident on the metal plate. So that's what we pour onto the metal plate. Electrons are released with zero kinetic energy. That means this is the minimum frequency needed. Okay, absolute minimum. The electrons are just simply going to get to the surface. They're not going to move. First question is to define work energy. It's the minimum energy, minimum, that's an M, energy of light needed to emit electrons from a metal's surface or from the surface of a metal. Okay. Now they want the work function of this metal. Now it's worth 6 marks. It's quite an old question, this. It would never still be worth 6 marks, okay? Because work function is hc over lambda. And I'm using this one instead of this equation because I was given the wavelength. I was given the maximum wavelength. So this becomes, whoopsie, I was about to write the wrong one. 6,63 times 10 to the minus 34 times by 3 times 10 to the 8. Those are all constants. Divided by 555 times 10 to the minus 9. 3,58 times 10 to the minus 19 joules. Straightforward. Definitely wouldn't be worth 6 marks anymore. Okay. Then they ask you, how will the reading on the ammeter change if the intensity, in other words, we make it brighter, of the radiation increases? Now, when we make it brighter, we mean that there are more photons. There's more photons, we're going to have more electrons emitted, okay? So the answer is it increases. Why? Light of a greater intensity has more photons striking the metal surface. Therefore, more electrons will be emitted. Now watch. Per second. Therefore, greater current. Guys, please don't forget the per second current is the rate of flow of charge. Okay. Incident radiation of longer wavelength is now used. How will the reading on the ammeter change? Now you've got to be careful, okay? Remember, C equals F lambda. C is a constant. if I make lambda bigger, I'm making frequency smaller. It's going to decrease. Already, we've only just reached that threshold frequency. In other words, this is the maximum length that I can have. If I make the wavelength any longer, the current actually won't flow. So because of the options, we would say decrease. But in reality, it'll become zero because it's now below, the frequency is below threshold. So you can't get any current going from that. Okay.